Hello friends, welcome to my channel. In this video we are going to discuss about the design of an encoder. So encoder, it is a combinational circuit that performs the inverse operation of decoder. So here the encoder, it is a combinational circuit that performs the inverse operation of decoder. Now observe this logic diagram. The total number of inputs here we are considered, that is the 2 power n are nothing but total inputs, and the n, which is nothing but the total outputs. So 2 power n inputs and n outputs that we mentioned here. So now, so to understand this, first of all, observe these two very important points, definitions. The encoder has 2 power n input lines and n output lines, which generates the binary code. This is important point. The encoder generates the binary code corresponding to the input values. Next, an encoder has number of input lines, only one which is activated at a given time. Like this 2 power n input lines, the number of input lines, only one input is activated at a given time and produces an output depending on which input is activated, and produces an output depending on which input is activated. So this is the second important point here in this encoder to understand this, right? So 2 power n input lines and n output lines, mainly the encoder job is to generate the binary code corresponding to the input value, right? So, and the second important point, out of those inputs, only one input is activated at a given time and produces the output depending on which input is activated, right? So that we will see with the help of example. You can understand easily the second point also. Now let us consider the example, that is octal to binary encoder. So octal to binary encoder means it is having 8 input lines and 3 output lines. That is nothing but the octal to binary encoder. Now let us see the logic diagram of this one, octal to binary encoder. So this is the octal to binary encoder logic diagram. So 8 inputs and 3 outputs. That 8 inputs are nothing but the data inputs. You can observe here from D0 to and D7. So all these are the inputs, and the outputs are observed here from X, Y, Z. These are the outputs, right? From D0 to D7, that means total 8. From D0 to D7, which is a total 8 inputs and 3 outputs. Observe here, this is nothing but 2 power n into n in the form of, where 2 power n, which is nothing but 8. So this we will mention, we will write here 2 cube into 3 itself, right? So where n is equals to, that means where n is equals to 3 itself, right? So this is the octal to binary encoder logic diagram, logic symbol. So now the point is here, now with this we need to understand the truth table. So observe here, from D0 to D7, the number of input lines are nothing but D0 to D7, or these are the input lines, and output lines are nothing but X, Y, Z. Now the point is, out of all these inputs, if you observe here, only one input is activated at a given time. Now observe here, so this first one, this first row, only one input is activated, that is only D0 is activated. Observe this second row also, only one input is activated, that is only D1 is activated. All other inputs are 0, only D1 is activated. For that, the output, which is depending upon the corresponding input value only. So the corresponding input is D1. So now it generates the binary code for this D1. So anyway, the binary code for this D1, which is nothing but 001. For example, observe this particular row, only one input is activated at a given time. So that means only D5 is activated. For this D5, the binary code, which is nothing but 101, right? So this is the output. X, Y, Z are the outputs. So in this way, it is generating the binary code for the respective inputs. Observe here, this is the last one. For example, out of all these inputs, only one input is activated, that is D7 is activated. Corresponding input, the corresponding output for the D7, which is nothing but 111. That means the binary code it is generated here. For this D7 input is activated. For that, the corresponding binary code is 111, right? Next we need to design the, we need to implement the logic diagram. So for that, uh, what are the outputs here? X, Y, Z are the outputs. Whenever this X is activated, that means here in this observe the column of this X output and Y output and Z output. The X is activated here in D4, and whenever the X is logic high, the respective inputs you need to consider. So to draw the to write the expression for X and Y and Z, first of all we need to consider this X. Here the X is logic high. The respective inputs are nothing but D4, D5, D6 and D7. The X is logic high. Similarly, observe the Y column, Y output. Y is activated here. That means the respective D2 and D3. And here next one it is D6 and D7. That is what we mentioned here. And similarly Z is active high. The corresponding input binary, which is the corresponding input which is nothing but D1, this one, and here this is respect to D3, which is input is activated, or next D5 and D7. So this one and this one. So all these are the outputs of X and Y and Z, the output expression X, Y, Z you can observe here, right? So now if you observe here, these outputs, the D naught is not present here. That means here we are going to consider the D naught is don't care condition. Now with the help of these expressions, now we need to write the, we need to implement the logic diagram. So the expression observe here, the same thing I mentioned here, X expression, that is D4, D5, D6, D7. So here I am considering the data inputs from D1 to D7. So if I want to represent the X output, means D4, D5, D6, D4 plus D5 plus D6 plus D7. So that I mentioned here with the help of OR gate. So D4, D5, D6, D7 inputs I am consider. Those inputs are given to one OR gate. So that is that is what our required output, X output. And similarly Y output, which is nothing but D2, D3, D6 and D7. So D2, D3 and D6 and D7, which is considered here. And similarly Z output D1, D3, D5, D7. So D1 it is considered here, D3 and D5 and D7. So this is the logic diagram of this octal to binary encoder. Hope you understand this. For example, what are the examples of this encoder? So the examples of encoder, which is nothing but octal to binary. So just now we discussed now, that is 8x3 encoder. Next decimal to BCD encoder. Decimal means total 10 inputs we are considered here, and BCD encoder means BCD which is a 4-bit BCD. Generally BCD code which is nothing but 4-bit BCD. Next hexadecimal to binary encoder. Hexadecimal means 16 inputs we are considered and 4 outputs. So these are the some examples in this encoder. So hope you understand this video. So please like, share and subscribe my channel. So if you like this video, please share this video to your friends also. Thank you.